So many people will find it difficult to solve this equation right here. So what we have is x power x is equal to 25. Okay, so how do you find out the value of x that possibly is actually going to satisfy this interesting Olympiad problem? Okay, so it is just pretty much cool. What I'm going to do is just to go ahead to take the natural log of both sides. Okay, so if I do that, I'm going to be having natural log of x power x is equal to the natural log of 25. And then using the property of logarithm, I'm actually going to bring this power down here to the base. So I'm have x multiplied by natural log of x is equal to the natural log of 25. Okay, one of the interesting tools we often use to solve this kind of problem is the Lambert W function. It's an interesting function which you may actually want to go ahead and find out more information. Of course, I've also done a whole lot of videos using the function to also solve so many other related problems, so you can actually check those videos and then see how that can also be useful to you. But for here, we're actually going to be using that to also simplify these problems so that we can find out the value of x. And so, like I've always explained in each of my videos, each time you want to apply the Lambert W function, you want to make sure that you have your function in the form of a exponential a, so that once you apply the Lambert W function, it's actually going to collapse whatever you have here to be equal to a. And of course, it makes the work very much interesting and easier for you to solve. So our job is just to go ahead to see how we can simplify this left hand side to be in the form of a exponential a. And of course, we can just achieve that by making some substitution for x. So we can actually write x as exponential natural log of x. Okay, and of course it is still pretty much same, because when you take exponential of natural log, it's actually going to give you 1, and then 1 times x returns you to 1. Okay, so in place of this x I have right here, I'm actually going to write this exponential natural log of x, so that I'm going to be having exponential natural log of x multiply by this natural log of x right here. Okay, and of course is equal to the natural log of 25. Okay, so this is what I have at this point, and then I can go ahead to actually rearrange this so that it can be in the form of a exponential a, just like I explained a few minutes ago. Okay, so I'm going to be having natural log of x exponential natural log of x is equal to the natural log of 25. So you can see clearly that we've caused our function in the form of a exponential a, where a in this case is natural log of x. Okay, so now I can go ahead to apply the Lambert W function. So I'm going to be having Lambert W function of natural log of x exponential natural log of x is equal to the Lambert W function of natural log of 25. Okay, and then of course this whole side is actually going to collapse to natural log of x is equal to what we have at the right hand side. So this is Lambert W function of natural log of 25. Okay, and because of course we are looking for the value of x, what we may want to do next is just to take the exponential of both sides. So if we do that, we're going to be having exponential natural log of x is equal to exponential Lambert W function of natural log of 25. Okay, and then of course at this point exponential natural log is equal to 1 times x remains x. Okay, is now equal to what we have right in exponential Lambert W function of natural log of 25. This is actually an answer to the problem we are solving, but then you may also want to find out the decimal representation of what x is. So you can move over to wolframalpha.com to find out the value of exponential Lambert W function of natural log of 25. And so when you check it, you're actually going to be seeing that x is approximately 2.9632. Okay, so this actually the approximate value you are going to be getting if you compute this from alpha.com. okay, so I hope you've got some value in this video, and do not forget to subscribe to our channel, like this video, and I'm going to see you guys in my next video. Bye.